I think these have got better as they've gone on. I might actually continue to use these. It's less work for me. Right, final landforms video. You've done all the erosion landforms at this point. Just spits and bars to go. Deposition of landforms, remember, that's the laying down of material faster than the removal. Sand spits, you only have one example for this. It is Dawlish Warren. You have to use Dawlish Warren. There is not an example within St Austell Bay. Definition of sand spits there to begin with: a narrow tongue of sediment that sticks out from a headland into the sea. Your named headland is Langstone Rock, and it will stick out into the river mouth, which is the River Exe. If I can just draw your attention to the diagram quickly, hopefully you can identify that the sand spit does not reach the other town across the other side of the river. That is Exmouth. We'll come back to the reason for that in a moment. Also within the diagram, you may well be able to spot the mudflats and salt marshes in that diagram, or in the photo I should say as well. I'll try and get the laser pointer to work. Salt marshes in here, mudflats, a wider area of mudflats stretching into this area where the laser pointer currently is. If I leave it there, that's the area for your mudflats / salt marshes. The sand spit at Dawlish Warren is 2 kilometres long, 500 metres wide at its longest point, and you may well be able to see some examples of your woodlands forming in here, your climatic climax spoken about on the previous sand dunes video. Right, crucial understanding to begin with here. The red line, or drawn on paint obviously, over a map of Dawlish Warren shows the change in coastline direction. If you were to look at the right at the bottom of the diagram or the photo, just to make it easy, you can hopefully see that it follows a northeasterly direction to begin with. However, when it gets to Langstone Rock, where the arrow is, can you see that it swings north at that point, so you get a change in coastline direction. So from Langstone Rock you get a change in coastline direction to the north. You can only get sand spits, well, at GCSE level you can only get sand spits where there is a change in coastline direction. The coastline directs north along the banks of the River Exe. Crucially important, any question about the formation of a sand spit, you must start from a change in coastline direction. So how are sand spits formed? Just the generics to begin with. The coastline will change direction, and what that means is sediment such as sand and shingle, transported by longshore drift, shown there in the bottom left hand corner, can be built up in the sheltered areas of the headlands. So the headland acts as a barrier, and it enables sand to be built up in a position where the waves cannot wash it away. If you look at the diagram of Langstone Rock there in the bottom right hand corner, any sand that you see in behind Langstone Rock, if I just direct you to the black arrow quickly, that's where the waves are coming from, the southwest. Any sand that's found behind that rock is protected from the southwesterly winds. It will be deposited there and it will build up at that location. So really important, we have to identify a change in headland direction and longshore drift to be able to make our point. So in terms of specific explanation then, Dawlish Warren has a prevailing wind with an 8,000 kilometre fetch stretching all the way from South America from the southwest that transports material in a northeast direction. The waves here, such a long fetch means that the waves are very powerful here. It means they can transport a lot of material in suspension and saltation, and in addition they are very erosive waves here at Dawlish Warren. They can erode Langstone Rock quite substantially every year, and that also means you have even more material in the sea in this area of South Devon. Where the coastline changes direction at Langstone Rock, material will be deposited in the sheltered areas, essentially to the northeast of Langstone Rock, where the southwest waves simply cannot reach them. The black arrow there on the diagram in the bottom right hand corner is showing you the general direction of longshore drift in this example, and the idea that material is moving in that direction. Right then, yeah, that's a paint diagram. Dawlish Warren Part 2. So as your sediment begins to build up, storm waves throw larger materials onto your initial build-up, making it more fixed, more static. So materials like boulders, like even driftwood, can be thrown up onto your initial build-up of sand, and that makes it more fixed and static, and it also ensures that it's actually above the level of the sea. In addition, future storms can add more material to it, But crucially, that process of longshore drift continues, moving materials from the southwest to the northeast, and they are also going to be deposited in this place because it's a sheltered area. That therefore means that the sand spit, you can see in the diagram, that orange, just little starting point, begins to build out and protrude into the River Exe. Just to repeat, the sand spit not going to be eroded because it's sheltered from the southwest waves by Langston Rock. So waves are going to be crashing on Langston Rock and not crashing so heavily on the start of the sand spit, so the sand spit doesn't get washed away. The River Exe also will potentially be able to erode it at this point, but because it's in such a small build-up to begin with, that actually it managed to stabilise itself before the River Exe can wash it away. What then happens is that continuing process of longshore drift means that more and more material is added to the sand spit, and it then extends out into the mouth of the River Exe. Just to point out here, the material from Langston Rock that's being eroded, that breccia, is also added to the sand spit at this point, and it means that it becomes more and more of a solid structure on the grounds of how much material is being deposited there. The river directly in behind the sand spit becomes slowed. As it reaches the sand spit, it's redirected, and actually what that will lead to eventually is deposition in those areas, because you get stagnant water, and that will eventually lead up to our salt marshes and mudflats being formed in that area because the river will deposit its load. So that process of longshore drift from the southwest continues to move materials northeast out into the River Exe. The final section, the spit does not reach all the way across the town of Exmouth, that you can hopefully now see on the diagram, because the River Exe is simply too powerful and it will erode the end of the sand spit through abrasion, hydraulic pressure, etc., etc. The end of the sand spit becomes hooked because storm winds from the east, generally speaking our waves and wind come from the west, however when they come from the east the sand spit will not be protected, it will be exposed, and that will be pushed inland by those storm waves, and you get a hook on the end for that reason. The hook's technically called a recurve lateral, but if you were to call it the end of the sand spit becomes hooked at GCSE level, that would be appropriate. There's your final diagram of Dawlish Warren from above. Should you get a sand spit question, I really implore you to draw a diagram of it in the exam, as it will make the points you're making make far more sense. Something that could be added to this diagram, and it would be a really good point of practice to do so, would be to actually add the longshore drift direction on. So draw an arrow from the southwest going northeast as your swash, and then draw an arrow directly back at a right angle for your backwash to show which way the material is moving up Dawlish Warren Sandspit. One little last bit here. If the sandspit did actually stretch all the way across and join to Exmouth, although it never would in that place because the River Exe is so powerful it wouldn't actually occur, it would always erode the end away, it gets a new name which is a bar. Worst case scenario in the exam is you get a question that says explain the formation of a bar. What you have to do is use Dawlish Warren as your example, explain how a sandspit is formed, and all you do is just add that little sentence on the end saying when the sandspit joins with the opposing headland, this then forms a bar. The reason it joins is exactly the same as the sandspit formation, it just reaches across to the other headland. Hopefully you can see it there with a diagram. You do get a lagoon forming there as well. Final slide here is a most able slide. It's quite a tricky little addition, but if you were to get a sandspit question, you could use this as your extra twist to try and really show the examiner your understanding. In addition to longshore drift, the evidence suggests that Dawlish Warren probably was actually originally formed by a rising sea level, and the reason for that is Dawlish Warren's made up of chert and flint, which you don't find in the local area, so it must have come from somewhere else. The idea being that out in the English Channel 20,000 years ago there simply was no water, but there were these lines of chert and flint within the English Channel, which was a dry seabed at that point. As ice on the land begins to melt and rushes into that area, that chert and flint becomes more buoyant and is held up through suspension, and it essentially, through traction, suspension, saltation, rolls itself towards the land as the sea begins to rise in that area, It just so happened to be that 6,000 years ago, when sea levels essentially stabilised to the point where glaciers weren't melting as much anymore, that it just happened to drop it there at Dawlish Warren where it would be found today. The argument being that longshore drift only recharges the sandspit as opposed to actually formed it in the first place. Quite a tricky concept, this one. It's probably one I'll go through on a Friday revision at some point in the not too distant future. Come and ask if you're not sure about that, you want me to go through it, because there's a couple extra diagrams I could do to show it, but I'm not going to do it on this video because it might take me 10 or 15 minutes longer. That sandspit's done. You've got to remember change in headland direction, longshore drift, the concept that it's sheltered, and the idea that that longshore drift builds up the sandspit because it is sheltered. Anything you're not sure of, come and see us down in H.